In this video, let's discuss the slope of a line and find the slope of a line given 2 points. So remember, the slope of a line measures its rate of change or its steepness. Sometimes we say that the slope is given by the rise over the run. That's the change in the y values divided by the change in the x values. And that ratio is constant for a linear equation. Here's some different examples of graphs of linear equations that we might see. So in this one, the slope is positive. The y values are increasing as the x values are increasing. This one, the slope is negative. The y values are decreasing, going downwards as the x values increase. The more negative this is, the steeper it will go downwards, right? The more positive this slope is, the steeper it will go upwards. What about horizontal and vertical lines? They have unique properties when it comes to slopes. So let's think about a horizontal line using this definition, change in y over change in x. Here, there is no change in the y values. The y value is always the same. So this amount is 0. The change in y is 0. Then in the definition, we have 0 divided by some change in x. That just gives us 0. So we say that the slope of a horizontal line is 0. Let's test a vertical line using this definition. Slope is change in y over change in x. A vertical line has no change in the x values. The x value is always the same, right? So in this definition, that means this part, this denominator, is 0. It's like we're dividing by 0 here. Division by 0 is always undefined in math, and that leads us to say the slope of a vertical line is undefined. We can't give a slope for it. It's undefined. I don't say that the slope is 0. I say that the slope is undefined. We know that the slope measures rise over run, or vertical change over horizontal change. Then we can find the slope of a line between 2 points. If my points are x1, y1, and x2, y2, all that I need to do is to measure the vertical change and divide by the horizontal change. This represents the rise, y2 minus y1, that's how much it's changing in the y values, divided by the run, x2 minus x1. So I can use this formula in an example like the following one. Find the slope of the line connecting -2, -5, and 4, 1. We'll just plug those in to the formula. So the slope here is, I'll call this y2, so it's 1 minus -5. Pay careful attention to negative signs here, divided by 4 minus -2. And when we simplify this, 1 minus -5, that's the same as 1 plus 5. So I get 6 over 4 minus -2, that's the same as 4 plus 2, that's also 6. And so this slope simplifies to 1.